In this video, we'll be solving some problems based on the standard formulas for Laplace transform of the function t. Okay. So in this first question, we'll take it. Laplace transform of what? 6. It is nothing but a constant. So we know that Laplace transform of a constant a will be what? A by s. Right? Now, Laplace transform of 6 will be what? In place of a, it is 6. So, what will be the Laplace transform of a constant? It is nothing but a by s. What is a? That is 6. 6 by s. This is the answer for Laplace transform of 6. Okay. In place of a, it is 6. So, a by s. So, 6 by s. Move on to the next question. E power Laplace transform of e power minus 3t. Okay. Now here we know the formula, standard formula, Laplace transform of e power at. It is nothing but 1 by s minus a. Correct. Now here you observe that a is what? Minus 3f. Try to analyze that. Compare these two. This is nothing but a standard formula for e power at. This a is what? Minus 3, right? A is minus 3. So Laplace transform of this function will be 1 by s minus a. Instead of a, what you have to write? Minus 3, right? 1 by s plus 3. So this is the answer for the second question. So we will discuss few more problems based on the standard formulas. Now the third question we will discuss Laplace transform of t square. Okay. So we have the formula Laplace transform of t power n, which is equal to n factorial by s raised to n plus 1. Okay, this is a standard formula that we have discussed. Now try to analyze, try to compare the standard formula with this question. Now it is t power 2. That means instead of, in place of n, what is that? 2. So n equal to what? 2. Now you can directly write. So Laplace transform of t power 2 will be n factorial. What is n? 2. So 2 factorial by s raised to n plus 1. That means s raised to, instead of n, it is 2. S raised to 2 plus 1, which is equal to 2 factorial means 2 only. Now 2 s raised to 2 plus 1, that is s raised to 3. This is the answer. Simple question. Try to compare standard relation or standard formulas with the question. Okay. Now we'll move on to the next question number 4. So we will take some cos functions. So cos 60. So Laplace transform of cos 60. So we know that Laplace transform of cos 80 is nothing but what? See, cos is there, so s is there, so numerator s. Cos 80 function, so s square plus a square. Okay. Now Laplace transform. Here you observe what is a, in place of a, here it is 6. So in place of a, it is 6. Okay. So Laplace transform of cos 60 will be s by s square plus a. Instead of a, what is there? 6 is there. So 6 square is equal to s by s square plus 36. So this is the answer. Okay. So we will do few more problems. Now moving on to the fifth problem we'll discuss. We'll take cos hyperbolic. We can take 3t something. Okay. Cos hyperbolic 3t. We have the relation cos hyperbolic 8t, which is equal to what? Cos is there, so numerator s is there. Hyperbolic function, so s square minus a square. Okay. So this is the standard relation, standard formula. So Laplace transform of hyperbolic 80. In place of a, what is there? in place of a 3z. So a equal to 3 here. Okay. Now Laplace transform of hyperbolic 3t will be s by s square minus, instead of a, what is that? 3z. So it's basically 3 square. So it is s by s square minus 9. So this is the answer. Okay. Now we'll take some sine functions. To sine, Laplace transform of sine A will take phi t. Okay, phi t. So what is the Laplace transform of sine A t? Now, Laplace transform of sine A t we know, which is equal to, sine is there, so we have to write a numerator by 80 sine 80, so s square plus a square. Okay, so this is a standard formula. Now compare a with what? Phi. See, these two questions, this question you have to compare with what is the standard relation. See, a here, instead of a, what is there? 5 is there, so a equal to what? 5. Now, so Laplace transform of this becomes what? A is there, so instead of a we have to write 5 by a square plus, instead of a what you write 5 square, which is equal to 5 by a square plus 25. So this is the answer. Now we'll take last question, that is Laplace transform of sine hyperbolic will take 2t. Okay, these are all simple problems. Laplace transform of sine hyperbolic at is nothing but what? Sine function is there, so numerator will be a and denominator becomes what? Hyperbolic function, so s square minus a square. Okay, now so compare this with this. So sine hyperbolic 2t, so instead of a, what is there? 2. Okay, so this becomes Laplace transform of sine hyperbolic 2t becomes a by s square minus a square, instead of a, what is there? 2 is there, so place of a you place 2, so 2 by s square minus a square square. Okay, so 2 by s square minus 4. This is the answer. So we have discussed almost all the simple problems that are based on the standard or the standard formulas, elementary Laplace transform formulas.